All right, this is our first lesson in our Unit 1, which is all about gathering data. Today we're going to be talking about randomness. So, randomness, in order for something to be random, it needs to have two different things be true. The first one is that no one can guess the outcome before it actually happens. So, there is no way that you can predict the outcome. So, think about like rolling a dice. There's no way for you to be able to predict what number is going to show up on the dice, or flipping a coin. There's no way for you to accurately predict whether the coin is going to land heads or tails. Which also goes into the second thing about randomness is that the results need to be fair, and in most cases, they need to be equally likely. For example, when rolling a dice, you've got six sides of the dice. You need for those six sides to show up roughly the same number of times. Or flipping a coin. When you flip a coin, you would expect to get about the same number of heads as you would tails if you were to flip a coin for a large number of trials. Now, there's going to be two primary ways that we will talk about randomizing. The first is with a random digits table, which is basically a large table of random numbers that you can use to randomly generate numbers for different simulations you might want to do. The second is with the graphing calculator. So if you have a graphing calculator, you can use one of the features on it is a random integer calculator, which I will share with you guys in a later lesson as well. Let's talk a little bit more about what we're going to be using randomness for, which are these simulations that we're going to talk about. So a simulation mimics reality by using random numbers to represent the outcomes of real events. In other words, simulations are a way for us to study and to try to predict phenomena that we see in our world without actually having to do a trial. Like maybe I wanted to figure out what is the probability that Harrison Butker, the kicker for the Kansas City Chiefs, makes 4 out of his 5 field goals in the next game. Well, I can't exactly ask Harrison Butker to just come to the Shining Mission North football field and kick 5 field goals and see how many he makes. But I can run some simulations with numbers to give a pretty good estimate for how likely that is to happen. So some parts of a simulation. The first is a trial. So trial is each time we obtain an answer to our question. So again, if my question was how likely is it for Harrison Butker to make 4 out of 5 field goals, then after he kicked 5 field goals, I would look to see did he actually make 4 out of the 5 or not. And if he did, I would call that a success. And if he didn't make at least 4 out of 5, I would probably call that a failure. So that would be one trial. It would be going through kicking those 5 times and looking to see was it a success or was it a failure. A component is each repetition within a single trial. So within that one trial, I looked at 5 different field goal attempts by Harrison Butker. Now, each one of those would be a component. So each field goal attempt would be one component. So there would be essentially 5 components to it one trial. And the response variable is the trial's outcome. Usually we're going to keep it very simple and either call it a success or a failure. So again, with the Harrison Butker example, a success would be if he made at least 4 out of the 5 field goals. A failure would be anything less than 4. Let's take a look at another example. So the Baseball World Series consists of up to 7 games. The first team to win 4 games wins the series. First 2 are played at one team's home ballpark, the next 3 at the other team's park, and the final 2, if they're needed, are played back at the first park. Records over the past century show that there is a home field advantage. The home team has about a 55% chance of winning the series. Does the current system of alternating ballparks even out the home field advantage? And how often will that team that begins at home win this series? So let's think about each of these parts of this simulation that we might want to run. The first, what is the component to be repeated? So what is kind of our each individual thing we're going to look at? And in this case, that's going to be each game that's played. So each individual game that's played would be considered one component. Okay, for part B, how will you model each component with equally likely random digits? There's kind of two different ways that we can do this. So let's talk about how you would do it using a table and how that's different from using a calculator. Okay, so in a table, you have to make sure that there are two full digits for each possible outcome. If there's a 55% chance of winning, then what we would probably want to do is use the numbers 00 up through 54 as a success or as a win. And then we would let 55 through 99 be a failure. Or a loss, I should say. Now, you may be wondering why I chose 00 to 54. That's because if you include 0, you have to be one less than your number. So if you had 55, then if you did 1 through 54, that would just be 54. If you do 0 through 54, that's actually 55. Now, again, if you wanted to do 1 through 55, I suppose you could. So another way to do that, when we use a table, we also have to make sure there's two digits, which means for a single digit number like 1, we call that 01. I suppose you could do 01 to 55, then do 56 up through. You wouldn't want to do 100 because 100 would mean you'd have to do three-digit numbers. So you'd probably do 56 to 99, and then also say that 00 was also a loss. So you could alternatively use this as your table method. Calculator, a little bit more straightforward. For a calculator, you actually can just say the number 1 through 55 as a win, and then you could say 56 up through 100 as a loss. So the nice part about using a calculator is you get to use numbers that you probably would be more familiar with, probably be more comfortable with in the first place. Okay, so for C, how will you model a trial by combining elements? So let's talk about just maybe using a calculator. So we're going to use a calculator to generate a random number. We're going to classify that as a win or a loss. After we've done that for 7 games, so after 7 repeats, if there are more than 4 wins, that's going to be a success for us. And if there are less than 4 wins, that's going to be a failure for us. Okay, so then our response variable is going to be whether it's a success or a failure. And again, we've just defined those as above. So how will you analyze the response variable? We're going to look at multiple trials, which means repeating this a lot of times. So not just doing our 7 repeats, that would just be one trial. We're going to look at that multiple trials to see if home field advantage really exists. Okay, so to summarize, here are your steps to building a simulation. Step number 1 is to identify the component that you want to have repeated. So in our baseball example, that would be deciding whether each individual game was a win or a loss. 2, explain how you will model the component. So that's where we're deciding how exactly we're going to either use the table or use our graphing calculator to come up with each individual component. For 3, explain how you combine the components into a single trial. So that's where we talked about repeating that 7 times to do the full 7-game series. That would be all of our components into a single trial. Step 4, state clearly what the response variable is. So that was where we decided that anything greater than or equal to 4 wins would be a success. Anything less than 4 wins would be a loss. Number 5, run several trials. Usually you want to do at least 10. So that means that 7 components in each trial, 10 trials in total, means you're doing at least 70 components for just kind of one simulation. 6, collect and summarize the results of all your trials. So what you would do is look at in each of your trials, was it a success or was it a failure? And look at how many successes or how many failures you had for each particular trial. And 7, state your conclusion. So make your decision based off of the data that you got. Let's take a look at one more example and then we'll be done with this first section. So you're pretty sure that your candidate for class president has about 55% of the votes in the entire school, but you're worried that only 100 students are going to show up. How often will the underdog, the one with 45% support, win? To find out, let's set up a simulation. So describe how you will simulate a component. So a component, we're going to look at just one particular trial, or one particular component where we're looking at each student, whether or not they're going to vote for our candidate or not. So we're going to say that using a calculator, 1 through 55 is a vote for our candidate. We're going to let the numbers 56 through 100 be a vote against. For part B, describe how you will simulate a trial. Well, we expected 100 students to show up, so we are going to run 100 of each component. Now, for part C, describe the response variable. We want to see how often our opponent wins. So we're going to let anything where we have more than 50%, so greater than 50% would be a success. Anything less than 50% for our opponent would then be a failure. All right, that is it for our first section. In our second section, we'll be talking about some sampling basics, the different types of sampling you can do, and how that relates to our population and parameters of interest. Until then, have a great rest of your day.